So in this video, we are going to look at drawing a bell-shaped curve to represent normally distributed data. Now, we have here the heights in centimeters of 11 women shown below. Now, the first example is saying to construct a frequency table. Now, here for our frequency table, remember we need the score. So I've written all my scores here. We tally up, so we cross off and count how many of each score we get, and then we write a frequency, how many times that data point occurs. So writing this in here, I have 163 happens once, so it has a frequency of 1. 164 happens once, so it has a frequency of 1. 165, same thing. 165 happens 2 times. 166 happens 3 times. 167 happens 2 times. 168 happens once. And 169 happens once. So you can even see just by looking at it, we get a bit of a symmetry happening, right? Our biggest value is in the middle and it goes down as we go out. So we're already kind of expecting, just by looking at it, a normal distribution. So now that we've done this, it's asking us to find the mean and the median. Now, just to quickly recap what each of these mean. So a mean is essentially we add up all of our data points. So we add 163 with 164 with 165, etc. And we divide it by how many data points there are. So the question tells us that it's for 11 women. So we add these all up and divide them by 11. Now, you can pause and do this on your calculators, but I would just give you the answer. If you add them all up together, your mean, and we can show this using this symbol, this X with the bar on top, equals to 166 centimeters. Now, our median, remember, is our middle value. So our numbers are already arranged from smallest to largest. We just want to find the middle value. So we can cross off the ends and work our way towards the middle. And we can see that 166 is our middle value. So the median is 166. Okay, so next one, it's asking us, what is the population standard deviation correct to 2 decimal places? Now, this is basically just entering into a calculator. We've done this in previous videos where I've actually shown you how to enter this into a calculator. This video is assuming that you already know how to do that, but finding the population standard deviation, we use our calculator, and this will give you a value of approximately, so the population standard deviation is going to give you a value of about 1.65 centimeters. Okay, we're going to talk a lot more in detail about standard deviation as we go on, but right now we're just practicing making sure we can calculate mean, median, and we can find the population standard deviation. Now, really quickly, we've seen here that the mean and the median are exactly the same. Let's just check the mode is the same. So mode, remember, means most common number. And we can see from the table that our most common with the highest frequency is 166. So the mean, median, and mode are all the same. So this tells us that this will be a normal distribution. But we're just going to show this by actually plotting the bell-shaped curve. So we're plotting the points on a dot plot. So we're going to, I've got my axis down the bottom. We want to put these points in, count how many there are, and draw them up as a dot plot, and then we're going to draw our bell-shaped curve on top. Now, 163 and 164 each had 1. 165 had 2. 166 had 3. 167 had 2. And these each had 1. So I can see here clearly it's symmetrical about the mean. So I have my mean, median, and mode in the middle, and this is symmetrical. It looks the same on one side as it does on the other. So drawing our bell-shaped curve above, we get something that looks like this. So we get a really nice bell-shaped curve. And we got this because we already knew that this was a normal distribution. Why did we know this was a normal distribution? Well, for that reason we said before. The mean, the median, and the mode were all the same. But this is how we can graph up our data. We can write it as a dot plot, or even a histogram we have done in the past. You can draw this in any way you'd like, and the bell-shaped curve is just drawing a curve above the tops of these points. So we're essentially just getting a feel for the shape of the data. So we draw this curve above the points. As my number of dots get bigger, my curve goes up to a maximum, then it goes down on the other side. But that brings us to the end of the video. Thank you so much for watching, and I'll see you next time.